Yeah, I asked him yesterday after class, and he's like, "Oh, we might have, but if so, it'll be like a 5%." That's good, no problem. If you get that problem, that's like horrible. Yeah, I asked him yesterday. I don't know. But if so, it'll be like a 5%. That's good, no problem. Bye. Bye.
Oh, it's because he's zooming. Yeah.
All righty, no problemo. So we're going to start by seeing how you did on these problems right here. Welcome back to this beautiful Friday. I thought I recognized you even behind that. Just give me close the door. Yep. All righty. So let's see now. The answers that I'm going to give you, I think I've actually included number 8 as well, even though you didn't have to do it. So don't freak out when you see that. Not a big deal. So pull this over here. So here are the answers. There we go. So you can see here's the answer, and there's actually little solutions over here, but here are the answers. Just ignore number 8. You guys didn't have number 8. I got rid of that one. Okay. So hopefully you see how the answers are given to you there. Cross off and break.
Yeah.
I'm just going to go past the multiple choice. Can you guys read these? Okay. Is it hard enough? It's a bad angle. Let's see if. Does that help? Next page has the rest of it. So. Are we good to this point? So can I? And make sure everybody has those before we go on. I'm going to check attendance. Shoo-ba-doo-boo-boo, doo-doo-doo-doo. Da-da-da-da-dee. Let's see what we got here. Epicent. Good, good. All four. And missing true. All right. And there's number 70. Ciao. And then, of course, at this time, we will gladly do any of these problems that you want. Okay. Okay. So, yeah, what do we got here? 7?
70.
Oh, 70, the last one. Okay. All right. So let's go ahead. I'm just going to get out of here. And let's just go right here. And do number 70. Okie doke. Number 70. Here we go. Parking garage. Sound made by each of 5 cars in a parking garage has an intensity of 3.2 times 10⁻⁴ watts per square meter. What is the decibel level of the sound made by all 5 cars in the parking garage? So number 70 is using the same function that you had, I believe, back on the decibels number 62. So you have to use that exact same thing back here on all of these problems, okay? So for that, you're using the, where's that? Where did they give it to you at? I'm trying to see it with my glasses on. Gotta get some new ones. Where is that? Oh, there we go. Where is it at? Function in example 5. You have to go back to see example 5. So they got L of I equals, and then they gave you 10 times the common log of I over I sub O. So this is what they've given you back there in example number 5 for the function. So on this, what do we know here? Okay? Because back there, they've given you what these different things stand for. All right? So if you look back at that problem there, L of I is the sound in decibels. So we're going to write this. So this is sound in decibels. 10, it's constant right over there. And then they've given you the next things. They've told you that I and I sub O are what? I sub O is the intensity of a barely audible sound, which is about 10 to the negative 12, they tell you. And to the negative 12, okay. And by how many decibels? Okay, great. So what do we have to do here in this problem? Let's go back down to the original problem we had. So we've got the sound made by each of the 5 cars and parked cars has an intensity. So intensity goes where in this? Right here. That's where the intensity goes. Because we're trying to find out on this, then we want to find out the decibels. So we're calculating from the left-hand side. So it's 10 times common log of this, which they told us was 3.2 times 10 to the negative 4. Over. Now, on this problem here, what am I going to put in for I sub O? What do I want to put in? Do I use 10 to the negative 12 is the question. I gotta get some new glasses. Anybody got a good optometrist? Maybe, maybe not. What is, am I going to use 10 to the negative 12 here for this? Yes, no, maybe? You guys talk. In fact, I feel like I'm doing a Zoom meeting with you guys right now. Are we doing a Zoom meeting right now? What's that? I know. Come on, guys. You have to talk some. What do you think?
Yes.
So if I put this here, what would I do with this? Tell me how I would work with this if I wanted to simplify this. Any thoughts? How I would do that? You could expand it, I guess. When you say expand it, you mean expand the logarithms?
Yeah.
You could do that, yeah. If I expanded it, what would it be? What would happen here?
Log 3.2 times 10 to the negative 4.
Log of 3.2 times 10 to the negative 4. I'm going to put that in parentheses.
Minus log 10 to the negative 12.
Okay. Now what would I do? I could distribute the 10 at this point in time. Yeah, I could. Could I expand it any further than it already is? If I wanted, could I do this? Is this okay? Is that true? Or that first piece of the parentheses there? Okay. So now what? Now I can distribute the 10 to if I wanted to. Hey, real quick, I'm curious. Let's make this go. This would be 10 times. What am I going to get here? What is common log of 10 to the negative 4? Negative 4. And then this would be minus, what's the common log of 10 to the negative 12? What do I get there now? 8. That's a plus. So now it looks like it's going to be 10 log 3.2 plus 80. So then I have to find out what this is right here. And how do I do that? I could do power to power, but since it's a common logarithm, won't my calculator already do common logarithms? So I could just on my calculator type in the common log of 3.2. And I'm not sure exactly what that's going to give me, so I'll do it. So this gives me, this is not what they had. This is 10 times, what do I get here? If I do the common log of 3.2, it gives me about I'm going to say 5.1. What's this going to give me when I'm done? About what? About 85. That's not what they said it was, did they? Didn't they say it was 92? They said it's about 92 decibels. Unless I wrote something down wrong here. The sound made by each 5 cars. Oh, are there 5 of those? It says each one. I need to read carefully. The sound made by each has an intensity of 3.2 times. So what does that mean? Should I have 5 of these up here? So if I have 5 of those up here, that's going to make this become a log of what? What's this going to become? 5 times 3.2. Yeah, and that gives me what then? This should be 5 times this, guys, because I had 5 cars. I was thinking that instead the total of them was that. Each one is this. So I need 5 of those on the top. So this is going to be a 5 times this. Or I should say, that 5 is going to go there. And that means that 5 is going to be right here as well. And that 5 is going to be here as well. So then this right here ends up giving you something completely different when you do this. This gives you not 0.51, but 1.2. So that gives me what then? About 92. That's 12. See, got to read carefully, Jeffrey. That's me. I'm Jeffrey. Okay. All right. Any other ones you want to ask about? No? Oh, I'm sorry, Proxima. What you got?
Can you just like show 23?
23?
Yeah.
23 is log base 6 of, and I don't like I told, I don't like the way they write this. I like this better. I like putting that parentheses, make sure we understand that. I'm just going to do that there. They don't use parentheses like I do, but that's their choice, okay? So the instructions on this section was, it says expand the expression. All right. So to expand the expression, I'm multiplying in here. Okay, now there's a lot of ways of thinking of this. Okay, so I'm going to think of this as I'm multiplying 36 times x squared. That's a product property. So I can expand this and make it the sum of 2 logarithms. So that's log base 6 of 36 plus log base 6 of x squared. Now that's expanded, right? 36, okay, is the same as 6 squared. This is true as well. What happens here then? Comes a 2 plus, where does this go? Out in front, because it's the what property? Power property. Okay, now I'm not sure if that's exactly what they wanted to do. They may have just simply went ahead. Yeah, they left it like this. They just stopped right here, didn't they? So I think what they did was this. They went log base 6 of 36. Did they do this? that what they did? Is that the answer I gave you? Yeah, it is. Okay. You actually could simplify that more. It didn't ask you to simplify it, so you could stop right here. If you went to this, would I count that wrong? No way. That's still expanded. Okay. So I would count that. This one I would like you to get rid of the power. At least I'd like this right here for sure. If you went to this, I'd be fine. If you put the 2 out in front of me at log base 6 of 6, I'd be fine with that too. Did you have another one? Yeah.
I just have like a format question. For one of them, I left it as like 2 to the 5th, and you had it as 32, like on a test.
Okay, what section is that under? What number was it?
38.
Number 38 said to condense it. Yeah, if you left that as, I would give you full credit for that. I wouldn't care one way or the other if you did that. It's kind of like this, okay? If you left it like this or this, even if you left it like this, like I said, I'd like that too here, I'd be okay with that too. There's a little leeway on that, all right? Now, if I said, evaluate all real numbers or something like that, then I might take off of that. Most likely I wouldn't know. Any other ones you want to look at? No? All right. All righty. So I'm going to minimize that. Oh, we might need that. You never know. So today, we're going to start solving exponential and logarithmic equations. Today, we're going to start solving exponential and logarithmic equations. Okay, and we've already done some of that. In your notes, you guys actually did do some solving already. But we want to now start trying to solve maybe higher order, harder problems, all right? So the entire goal today is to solve exponential and logarithmic equations. That is our goal today. And it's all about using inverses for the most part. We won't always have to use inverses, but usually we will, okay? So we're going to start with 2 that are kind of easy, okay? These will be the type that when you get them, you should be like, yes, these I like, all right? Here we go. First one I'm going to give you is this. All right. Let's say I think it's a 2x plus 3 right here. There we go. So let's say I gave you this and I wanted you to solve it. Now it's an exponential equation because it has exponents in it. Usually I would tell you, oh, if it's an exponential equation, I should rewrite it as a what? Logarithm. This is a scenario though where I don't need to do that. The reason I don't need to do that here is because if the bases are the same, yeah, that's right, then set the exponents equal. If these bases are the same, then these exponential values have to be the same. So I don't have to use logarithms at all in this one. I would just simply say, oh, therefore, x is equal to 2x plus 3. And now I would just solve this. Okay, so that would be the type, if you get it, you should be like, yes, I like this problem. The bases are the same, set the exponents equal, solve it, boom, bam, slam, be done. So what happens? I subtract 2x from both sides. I get negative x equals 3, which means, of course, what? X equals negative 3. Am I allowed to have negative exponents?
Yes.
Yes. Negative exponents are okay. Think about the exponential functions. Like this. These are negative x values right here. Okay, positive x's, negative x's, right? That's okay. So there it is. Boom, done. That's the kind you should be like, give me a lot of those, Mr. Snyder. I can do that. So let's go one step more difficult. One step more difficult. Here we go. Next one. Wrote down some problems at the beginning before class started. All right. Here I've got two things. It's exponential. I've got them stay equal. First question, are the bases equal? And the answer is
No.
no. Second question, can I rewrite so they do have the same base?
Yes.
Yes. There we go. So this one I'm going to rewrite. I'm going to rewrite 49 as 7 squared. So now I'm going to get 7 to the 3x plus 4 equals 7 squared to the. So now I have to use what property? Power of a power. 7 to the 3x plus 4 equals 7 to the. Careful here. What am I going to get when I multiply this and this? 4x plus 2. Make sure you do what? You're multiplying it by the entire thing. You must distribute it through. Now the bases are the same, so I could just say, therefore, 3x plus 4 is equal to 4x plus 2. So I'm going to subtract 3x from both sides and subtract 2 from both sides at the exact same time. On the left, I'm going to get 2 equals. On the right, I'm going to get x. So there's my answer, x equals 2. Okay. So those are the ones that are probably the nicest ones. The nicest ones, of course, are these right here. The bases are already the same. Set the exponents equal. The second type, the bases are not the same. What? You try to rewrite so the bases are the same, and then set the exponents equal. Okay? So those are nice problems. Exponential. Let's look at a nice logarithmic equation that you should like getting. Okay, here we go. All right, so now this is not exponential, this is logarithmic. What do I notice about the base of both logs? Yeah, they're both the same. If you have two logarithms set equal and they have the same base, then what's going to have to be true? What's that? The other parts must be equal. Okay? If these bases are the same, then what you're taking the logarithm of must be the same as well. So this one, you would just simply say, oh, if those are both common logs, that means that 3x plus 1 would be equal to 2x plus 12. And now, again, I just solved this equation. And so I'm moving this way, subtract 1. Here, I'm going to get x equals, here, 11. Now, I do need to check these. Why? The previous ones, I didn't even check them. Why did I not even check over here for the most part? Why did I not even worry about it?
Because the exponents can be negative or positive.
Exponents can be positive or negative. Here, though, I do need to take a quick peek to make sure that when that value is plugged in, that I'm not taking the logarithm of a value that is 0 or negative. So as long as I can plug this into both of these and I get back a positive value, I'm good. Does it work over here for a positive? Yes, as a matter of fact, you get what? 33 and 1, which is 34. Over here, you get 44 minus, I'm sorry, you get 22 plus 12, which is 34. You get the same thing. You better get the same thing. But these have to be positive. If this would have ended up being negative 11, the answer would have been what? No solution. Okay? So make sure you understand that you check in that one. You check it. Again, those should be the type that you go, oh, I like this. Logarithms are the same. What I'm taking the log of, boom, set them equal and solve them. So far, are we okay? Okay, so let's see. I'm down. Okay, now let's get a little more difficult here. Here we go. Okay, and now I've got an exponential equation. I only have an exponential function on one side of it. Not like the other ones where I had 2 to the x on one side and 2 to something else. This time I only have it on one side. All right, so my first step is to isolate the base with variable exponent. In that case, I want to isolate e to the negative 2x. So how am I going to isolate, get it by itself? What's that? Fantastic. You guys can just say it out loud. You don't have to raise your hand on this part here, okay? So here, I'm going to get e to the negative 2x equals 6. Okay, now, once you have this done, in order to solve this, I will have to do what? Write it as a logarithm. So now I'm going to change forms. What will this be as a logarithm? Anyone want to say it out loud? Okay, so log base e is called what then? Natural log, ln. So it's going to be the natural log of what? Of 6 equals negative 2x. Last step. To get x by itself, what do I do? Divide both sides by negative 2. All right, now, here we go. This would be considered an exact answer. This would be an exact answer. Now think about where x is. X is an exponent. Do I need to really worry about it being positive, negative, blah, blah? No, not a big concern here. So this would be an exact answer. If I wanted an approximation, then you would take your calculator or you'd go to Desmos, one of the two. However, you're going to find your logs, your estimates, and you would just do the natural log of 6 and then divide that by negative 2, and you get about, I'm just going to make it negative 0.896. Any quiz or test we ever take, I will tell you where to round to. So you're not guessing. Okay? So I just decided to make that. If I want to know it's right or not, I could plug it in here, and it better be really, really close to 18, because I rounded it. It's going to be really, really close to 18. So there's another problem. So this one now we actually had to use the ability to go from exponential to logarithmic, rewrite its form. All right? That one okay? Well, good, right? It's not that bad. It's really not that bad, at least not yet. Okay, so let's see, where am I at here? Did that one? Oh. Okay. Now there's going to be a couple different ways that you can do this problem. There's multiple ways of solving this that are correct. Does anybody have an idea of what when they're looking at this, does anybody have an idea of what they would want to do first on this problem? Anybody at all? Yep.
I'd want to get rid of the third
root, so I'd put 12x to the 1/3.
Okay, so one option, I'm just going to draw an arrow here, is to think of this as log base 5 of 12x to the 1/3 power equals 2. I like that. Anybody else have a thought? Because that's not the only thought. I know it's not. Okay, nobody has another idea of what they would have, I mean, how many of you would have done that really? You would have, would anybody have just gone straight to exponential form? Yeah, what would it be in exponential form, Ryan, if I just decided to do that instead?
Would be 5 squared
Yep,
equals all that.
all this stuff here. That's true too. That's just as good. Okay. All right, so let's just go ahead and keep going on the left side, and then we'll go back and do the right side, and we better get the same answer. So on the left side, I have actually a couple choices here as well. Since you started, what would you do next?
I'd put it in exponential form.
You'd go to exponential form now. So now you would go and make this 5 squared equals 12x to the 1/3 power. So now it's a lot like what we have over there in the red one. Okay. All right. I'm curious. I'm just gonna, I guess it's, I said there was a couple options. That's one of them. Does anybody think, is there something else you could do if you're going on this route over here? You see? Yeah.
You could do power.
Power. You could put the 1/3 out in front if you wanted. I'm just doing all these because I want you to see that there's a lot of flexibility actually in doing these problems. You could go 1/3 times log base 5 of 12x equals 2. Okay, great. So this red one and this black one, the next step is kind of the same for both of them. Okay, so I guess what I could do here, I probably would say 5 squared is 25. So 25 equals 12x to the 1/3. And over here, I would do 25 equals the cube root of. Okay, so now if I was doing either one of those, what would my next step be? Because the next step's the same on both of them, really. The idea of it is isolate 12x. So how would I get 12x by itself here? Right? Yeah, raise it to the power of 3/1, which is the same as just raising it to what power? The 3rd power. What would be the next step here? Raise both sides to the 3rd power. Remember, all we have is 2 different forms: radical form, rational, and exponent form. They're the same problem right now. So here, okay, so here I get 25 to the 3rd equals 12x. Over here, of course, I get 25 to the 3rd equals 12x. So here, x would be 25 to the 3rd over 12. Here, x would be 25 to the 3rd over 12. Okay, probably would want a calculator to do that next step, correct? Okay, what if I had been doing this green path? What would my next step be? Yeah,
Put it in exponential.
I could, almost. That 1/3 is in my way. How do I get rid of multiplying by 1/3? Multiply both sides by its reciprocal. Multiply both sides by what?
3.
So I'd multiply the left-hand side by 3 and the right-hand side by 3. And I would get log base 5 of 12x equals 6. And now I would go to exponential form and I would get 5 to the 6th power equals 12x. And then I would divide by 12 and I would get that 5 to the 6th over 12 is equal to x. So my question is simply this. Hey, make it slightly. Are all three of these, we know the red and the black ones are the same. Is the green the same as the black and the red? How do you know it is? Without multiplying it out, how do you know it is?
Because it's 5 to the second. It's 5 to the second to the third.
This is 5 squared to the third, which is 5 to the 6th power. They're the same. All right, take your break, guys. Great, great, great. Dun, dun, do, 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 do. I'm going to heat up this little bit of coffee I got. Shabba-dabba-doo-doo. Next one. Do-do-bum-bum-bum-bum-ba-dee. Do-do-do-do. Let's check what's going on over here. So, submit. Man, what's going on here? My phone, nutso. Okay. Okay. This doesn't look right. That. that. Let's minimize this. Let's check our emails.
Oh. No, it's front and back. Time plus here. Then I have to snake the rest of the period. I had to like 200. Andrew at the 400. Andrew, let's go. What did you get on snaking? 450. I watched him do it. He was on, and then I tried to do it and I got 200. I get 200. He got 450 on snake. He did it on his like 5th try. Like the first try, he got like 1. I know, but I can't get 400. Yes, it was really important that I knew how to. True. But you can understand it. So. Good idea. Why would you help that? Well, just grab it right here and pull his hair. I didn't have to scratch my hand. Yes, I did on my hand.
Okay, well, let's go. Let's go. All right. So there we had a nice logarithm equation that we did solve by using exponential form. And we noticed that there were multiple ways of doing that problem. Here we go. All right. All right. So now I've got multiple logarithms on the left. I have 2 logarithms in the same base being added together. Okay. Now, if these were the same, I could just combine them into one logarithm quite easily by just saying it was 2 of them, but they're not. So now I have to use the product property for logarithms in order to do this problem. So we're going to condense the left-hand side. I cannot go to exponential form right now. So I'm going to go ahead and condense this. So it's going to become log base 5 of, and these are going to be what? Multiplied. Now I can either do it and write it down here, or I can write it down what the multiplication problem is going to be. If I have to multiply them, I might as well just go ahead and do it. So right here, we're going to get x times x, x squared, x plus 4x plus 5x plus 4 equals 2. Now that I have my logarithm isolated, one logarithm I can change to exponential form. So I get 5 squared equals x squared plus 5x plus 4. Which tells me then, this is 25 equals x squared plus 5x plus 4. So x squared plus 5x, and then what's going to happen when I move the 25 over? What am I going to get when I subtract that 25 from both sides to get it set equal to 0?
0.
Minus 21 equals 0. Okay. If I can factor it, I factor it. X squared, that's xx. Do I have two numbers that multiply to negative 21 and have a sum of 5? Almost. Darn, right? 7 and 3 would give me a. Does that work? No. So what does that mean? Doesn't mean no solution. I have to use the quadratic formula here. Okay, now before I go any further, I want to go back up here. I'm going to ask a question. What must be true about values of x? How about somebody in the far row give me an answer? What do you think? What has to be true about the values of x for this first logarithm? What do I know about x plus 4? It's not allowed to be what? Negative. How do I write that as an inequality, not negative? And it can't be 0 either. We don't take logarithms of 0. So x plus 4 has to be greater than 0. Over here, x plus 1 has to be greater than 0. What is this telling me? My values of x have to be greater than what? Negative 4. And for the other one, x has to be greater than negative 1. Now, do those overlap? So what do I know in general then? Yes, x must be greater than negative 4. So when I get my answer now, down here, I will know right away if something is going to be good or extraneous. So let's do this. X equals, okay, negative 5 plus or minus the square root of b squared minus 4 times a times c all over 2a, which is going to be 2. Inside there, I'm going to get 25 plus 84. All over 2. Now that's negative 5 plus the square root of, if I add those up, that's 109 over 2. And the other one is negative 5 minus the square root of 109 all over 2. All right. The square root of 109 is a little bit more than what? 10. Let's just say it's 10. Negative 5 minus 10 is negative 15. Divided by 2 is negative 7.5. What does that tell me right away? It's no good. I know that is extraneous. Without a doubt. So this one here, now look. What do I know this is going to give me back? A little bit more than 5. So I know automatically it is good. This is my good answer. This is the good one. That's the exact answer. I could just leave it there. Leave it. Done. I didn't have to use my calculator to get a decimal equivalent to see if it worked here. Because I know how to approximate. That's all I had to do was get an approximate to figure out if it was going to work. And this allowed me to easily go ahead and do it. If I don't do this, guess what I do? I approximate, I have to go up, plug it in, and see. Just find it right now, what's true about x. Okay? Anything that anyone ask? Any questions there? Oh, wow. Okay. I don't know. No questions is either good or bad. I'm not quite sure. All right. Let's do one that's going to look worse than it really is. Okay. This one looks worse than it really is. I want to solve this for x. It's exponential. I don't have two bases that are the same, so I can't just set exponents equal. So what should I probably do if it's an exponential equation? Write it as a logarithm. What would this be as a logarithm? Log base 11 of 33. How do I get x by itself? Divide by 5. So it looks like x is equal to whatever log base 11 of 33 over 5 is. Done. That's exact. That's an exact answer. It's a good answer. There's nothing wrong with that. I like that answer, as a matter of fact. There's no rounding involved in that one. Okay? So there you go. Not bad at all. Now let's go a little bit harder. Now let's go a little bit harder. All right, here we go. Okay, now, here this is like I started off on those, right? The very first one I gave you was 2 to some power equals 2 to some power. The next one was 7 to a power equals 49 to a power. The goal is to get them in the same base. 2 and 3. What do you think? Is that going to happen here? No. So now, how will I approach this kind of a problem? Any ideas how I could approach this? Yeah, what do you think?
Change both sides of the equation to make the bases the same.
How would I be able to do that? How can I get bases the same? I gotta be careful here.
The least common.
Like, is it possible? Could I multiply the left-hand side by 3 and the right-hand side by 2 to get the bases the same? And would that even get the bases the same? And is that a legal thing to do?
It would get them the same.
Would it even get them the same? If I'm just going to throw this out there. First of all, am I allowed to even do different things to both sides of an equation? No. So right away, I'm not allowed to do that. Second of all, does this even make this a 6? No, because order of operations says I don't multiply until I take care of the exponents. So either way, it's a great idea, but I can't do it. So let's not do that. Any thoughts? Yeah.
You could go log base 3 equals 2, log base 3 of 2 to the 3x power equals x minus 1.
Okay, so you're going to go ahead and choose one of the two sides. You chose the right. And you're going to write it in logarithmic form. Okay. So she said she's going to take this and rewrite it in logarithmic form. So there's the base. So it would be log base 3 of 2 to the 3x equals what? The exponent here of x minus 1. Now someone else could say, oh, I kind of did the same thing, but I didn't do that side. I did the left and wrote this as a logarithm. And they could write it as what? Log base 2 of 3 to the x minus 1 equals 3x. Either way, right? They're both okay. All right. So let's just do the one on the blue. I'm just going to look at the blue one. Because how we're going to approach them would be the same at this point in time somewhat, but like the technique we would use. I don't like having that 3x up there. What could I do if I wanted to? I got a couple different options here, actually. Yeah, right? Add one of those sides. I could add one of those sides. That's completely legit.
Would you do power of the power with the 2, 3x?
Say what now?
Would you start to do power of the power with the 2 to 3x and change?
So when you say power, do you mean rewrite this inside, or do you mean take this exponent and get rid of it in there? Is that what you mean? You mean the property of logarithms one?
Yeah.
Oh, you're saying the power property.
Yeah.
Oh, power property. Okay. So she thinks do the power property, which means I can take this 3x and kick it out in front. That's an option. If I wanted to, could I just bring the x out in front? Would that be okay? If I think of it as power of a power, I could do that, correct? 2 to the 3rd raised to the x power. I could just bring the x out in front. But there's a lot of options. So let's say I go ahead. Most people probably wouldn't think of it that way. Let's just kick the 3x out in front like this. Okay. Now, we know whenever we're solving equations, I have to get my variables on one side. So I would now need to somehow get my variables on one side. I know I'm going to just go ahead and bring this x over to the left. Okay? I'm going to subtract an x from both sides. Now, when I do this, watch what happens. I'm going to get 3x log base 3 of 2 minus x equals -1.
Why wouldn't you just subtract that from the 3x?
Because this is being held on my multiplication. They're not like terms. Okay? Yeah. You sure?
Couldn't you taking this to x out and then divide it by x both sides?
Okay, if you divide by the variable, you lose it. You don't want to divide by the variable. But your thought, you're kind of got a thought I like. No. On the left-hand side, guess what I'm going to do? I'm going to factor out the x. I'm going to factor it out. How many do I have right now? 2. If I factor out, how many will I have? 1. Factor out an x. What do I have? X times 3 log base 3 of 2 minus 1 equals -1. Isn't that what you get? How do I get x by itself now? Divide by what on both sides? The thing in parentheses. Oh man, x is equal to -1 over 3 log base 3 of 2 minus 1. Let's make that -1 look a little nicer. And since x is an exponent, do I have to worry about it being positive, negative, blah, 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 blah? No, I don't. Now that's kind of gross, isn't it? That's a lot more gross than the other ones. Now, if I did this, I would probably approach it in a very similar way. I'd put the x minus 1 out in front, right? And then I would go ahead and I'd have to get my x's on one side and I'd have to go ahead and factor out an x. It would look very similar in style. I want to try this problem another way instead, though, if you don't mind. I'm going to try it a different way. So 2 to the 3x equals, and I'm going to actually, I'll just go ahead and go to a new page. 2 to the 3x, 3 to the x minus 1. Okay. So here's my, before I do this problem, I'm going to ask you a question. If x equals 2, this is just a general question. If x equals 2, then does the common log of x equal the common log of 2?
Yes.
Yeah. What would this be true? Log base 3 of x equals log base 3 of 2. Would that be true? It wouldn't matter, right? If I have two quantities equal, and I could say log base whatever I want of both sides, and I'm going to have a true statement. That's my thought process right now. That's my thought process. Here we go. Guess what I'm going to do? I'm going to take the log of both sides. Now, what I choose to use is my choice. But I have two bases, and I'm going to use either base 2 or base 3. One of them. Owen, 2 or 3, what do you want me to use? All right, here we go. What happens right here? The log base 2 of 2 becomes a nothing, and you get 1 on the left-hand side. 3x. Remember? Remember what we said? If you have log base b of b to the x, what's that equal? X. Look at that. Okay. So now I have this. Now what can I do with that x minus 1? Right over here, I can do what? Put it out in front if I want. Okay, let's keep going. Now what? How am I going to work with that now? How am I going to get my, hold on a second here. I got to see what this is. I'm sorry. Oh. Okay, it was pretty short and sweet. What am I going to do with that now? What's that? I have to be careful, by the way, with the way I wrote this. This x minus 1 is being multiplied by this. This should really be in what, by the way? Parentheses. A little careless in my writing there. I know what it meant, but I want to make sure you guys understand. Okay, now what do? How am I going to, yeah.
You divide by x minus 1.
Okay, so I get 3x over x minus 1 equals log base 2 of 3. Good. Man, now what am I mean, that's yucko. Is that going to help me? No. I mean, it looked like it was going, and it's everything I've done is allowed. I mean, all worked out kind of nice there. Here's where I don't want to, I can do what I just did, but I'm going to go back a step if you don't mind. This is fine. Guess what I'm going to do right here? I'm going to distribute this log base 2 of 3 through on the x minus 1. Isn't that what this, I mean, if I gave you this, wouldn't I take 3 times x and 3 times negative 1 to get rid of the parentheses? So I would do the same thing here. So I get 3x equals x times log base 2 of 3. Then what? That's this times this minus what?
1 times log base 2 of 3.
Just log base 2 of 3. Now I can get my x's on one side so I can factor the x out. On the left, factor out a what? Factor out the x. Now they're the same. Numerically, if you calculated these, they'd be the same. All right. Those problems are a little more difficult. No doubt. If you have two bases, two exponentials set equal, and the bases are not the same, like this, and you can't rewrite them the same, that becomes more difficult. Whether you do it this way or you do it that way. That idea of factoring out the x comes into play. All right? Factoring out the x. Okay. You didn't like that problem as much. I know. I understand. Unfortunately, I've got one more, I think, for us to do. Yep, here we go. Last one of practice for us until I give you some problems to try tonight. Okay. Now, if these were the same base, you would just set those equal to each other. Okay. So this is kind of like the last problem, is that what happens? I've got two bases that are not the same, that idea. What am I going to do here? Yep.
Do 3 to the log base times 6x equals x.
Oh, rewriting that. So write 3 to this power equals x, is that what you said? So one option is to write this. 3 to the log base 9 of 6x equals x. Okay? You have a different thought? Yeah. Make the bases the same?
Like 3 squared.
So have I ever done anything where I made this 3 squared down here?
Yes.
In the base of the logarithm, have I done that?
Or not in the base, but
Yeah, I wonder if I can do that or not. That's a good question. I mean, if I wrote this, I don't know what that tells me right now. They're still really not in the same base, are they? That log base 3 squared is still base 9. I like the idea. It was kind of a cool idea. Kind of looking out there like that. What do you think? Anybody else have any thoughts on this problem? About what we could potentially try? I mean, both things that we've done they're true. They're definitely true. one wants to take just a shot and just look. You gotta try sometimes. Well, if I did this, what's that going to do for me now? Oh, what were you going to say? I'm sorry.
Oh, I was going to see if like you could expand log base 9 to 6x and then change the base to 3.
Oh, so you're giving me another possibility. You're not going with one of those. This is the third. Okay, that's fine. Cool. I like that idea. So his thought is expand this using the product property. So I could do that. I could make it log base 3 of x equals log base 9 of 6 plus log base 9 of x. That's what you're saying to do? Okay. I can do that. Yep, that's true too. So I've got 3 different things now, 3 possible options on how to start this. Let me group that. Smaller. So if you're looking at it, does anybody see anything on any of those that would allow them to go to a new step? Anybody? No? I have a question for you. Just a hypothetical question. True / false. This next question. Don't say anything out loud. I want everyone to think before you say anything. True or false? What do you guys think? True or false? Anybody want to just take a shot in the dark? 50-50 chance if you're just even guessing, guys.
False.
Ryan, what do you think? You think it's false?
Isn't it true because it's the Cobb principle?
Oh, Cobb. Change of base formula. Log base 3 of x is, Cobb would say that this is equal to log base b of x over log base b of 3. As long as these bases are the same and these weren't allowed to be equal to 1, if you recall, that's what we said. I just chose my base to be base 9. Why? Because then everything's in terms of base 9, isn't it? See, if I do this, I can replace the left-hand side with this. All right, so what looks horrendous, I'm going to continue using this. Now my left-hand side is this, and it is equal to log base 9 of 6x. Hey, maybe I should multiply both sides by what? Or I could divide both sides by what?
Students and staff, pardon the interruption. At this time,
Retakes, anybody?
sophomores with last names L.
No? Okay, we're going to keep going.
To head
Could I do this?
the auditorium lobby to get
Log
pictures.
base 9 of x is equal to
Again,
log
that's all
base
temporary.
9
We're
of
getting
3
pictures retaken.
times log
Last
base
names
9
L,
of
C. Thank you.
6x. Is that true? I just multiply both sides by log base 9 of 3. Is that true? Yes, no, maybe? What do you think? Yes. Okay. Hey, guess what? Guys, there are so many things I can do right now. My mind's just going a path and I'm going with it. And sometimes you have to just say, I'm going to head this way, and if it doesn't work, I will reevaluate and start anew. I'm just heading some way here. Here we go. Is that true? Is 9 to the 1/2 power the same as 3? Oh my goodness, so what do I get here now? 1/2. Guess what? Let's keep going. Now what do? What? Power. Is that true? That's where we're at now. Now I have two logarithms in the same base that are equal. What would I say? Therefore, x is equal to x would be equal to 6x to the 1/2 power. What do? Square both sides. It's quadratic. I factored it. Do they both work in the original equation? Nope. What doesn't? Out of there, 0. You're gone. You're gone. You cannot be used. Remember yesterday I said change of base can be used to solve? There it was. I used change of base formula to help me solve an equation. Because you wanted to get the bases the same. And the only way to do that is using a change of base formula. That's what we did. Right here, we went Cobb on this thing. Okay. All right. Woo! Oh yeah, I love it. The last example for the day. Now you're going to see a worksheet with 18 problems. You're not doing all of them. I'm just going to select some at random off of here. Okay. Just going to select some at random. You goobers at home, this has been posted online. You bet. Okay, let's see here. What problems shall we do, I wonder? Let me see something here. Oops, that's not what I wanted. My bad. Move that out of the way. Okay, here we go. You ready? Let's do number 6. Oh, number 2. And I would like you to give me exact answers for all of these. Okay? That means you do not have to stick them into the calculator. You can leave answers like natural log of 3. So exact answers for all of these would be appreciated. All right? Let's see here. How about number 8? I like that. That's a nice problem. I'm jumping back and forth. I should just go down one side. How about number 4 on the front and number 10 on the front as well? So on the front, 2, 4, 6, 8, 10. Hey, evens. What do you know? I just chose the evens. Okay, let's go to the back side. Now you'll already notice on the back I have circled 17 and 18 and they got cut off. They're circled because it says we're going to do those on Monday. So 17 and 18, you can just write next to those. We're going to do those on Monday in class together. We're going to look at those. All right. So don't do those. But the ones I would like you to do in the back are the following. Would you please do number, I don't know. How about number 11? I like 11. 11 is a nice problem. How about number, what do I want? 12 or 16? 12 or 16? I like number 16. 16. 13 or 14? 14, sure. And then you'll notice I've got one that says extra. I added that already because I wanted that. That's going to be one you have to think about a little bit more. Okay? Think a little bit more about that one. That's a little harder one. The extra one is. All right, those I'd like you to have done by Monday so we can go over them at the beginning of class. Okay? So you just have a little bit of time here. You can start working on those. Oh yeah. Bum, ba. Yeah.
Is that on the extra, is it 6 to 2x minus 2? I got it.
Oh, it did. It's 3 to the x plus 4 equals 6 to the 2x minus 5. I'm sorry about that. Yeah, it did get cut off. So again, on the back, the extra is 3 to the x plus 4 equals 6 to the 2x minus 5. Okay. Ciao. Good, 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 good. Shoot, doop, doo, ah. I will post
Yeah.
all of this online, by the way, for you, so you can go back and look at them if you want to. La, doo, 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 doo. For those of you who are online right now, if you have any questions, get a hold of, send me an email, and we can live Zoom anywhere from 2:10 to 3:15 today. Just let me know, okay? Otherwise, I hope you guys all have a wonderful, fantastic, fabulistic weekend. Woohoo! Stay warm, guys. Hey, break out the warm clothing for next week.
You get a homework assignment, I think, to Tuesday or Monday. And you get-
Ow.